Number 11 is a maximizing the volume of a cylinder problem. My restrictions are that the height and the radius, so I'll write this, h plus r, has to be equal to 100 centimeters. Well, I know that the volume of a cylinder is equal to pi r squared, which is the area of the base, times the height. From this guy, I know that the height is equal to 100 minus r. Yeah, 100 minus r. So I can go ahead and plug that in and get v in terms of r, and that's pi times r squared times 100 minus r. Now you may say to yourself, well, why did he solve for r and not for h? Or sorry, why did he get a function in terms of r and not in terms of h? Well, I could do a similar thing and solve for r in this equation, but then I would have h's and I would have to square it, and I like having my squared term be the more simple one. I'd call this more complicated and that more simple, and I think that it's easier to deal with the squared term being more simple. So, what I'm going to do now is multiply this out. I get 100 pi times r squared minus pi times r cubed. And that's my v in terms of r question, or v in terms of r equation. So now I'm going to find dv dr. dv dr is equal to, or you can just call it v prime, whatever you want, really. Not doing related rates. Don't worry about that. So I get dv dr. Do power rule. That gives me, for this guy, I get 200 pi r. So 200 pi r. And then for this one, I get minus 3 pi, pi r squared. I want to set this equal to 0 because it's my derivative. And I want to find a critical value, and that's when it's equal to 0. So I get 0 equals, and I'm going to factor some things out right now. I could factor pi times r out, and that gives me 200 minus 3r. Is that right? Yeah. So, one critical value is that r equal to 0, which contextually, in terms of looking for a maximum volume, doesn't make any sense in this problem. I don't care about a problem where the radius is equal to 0. That's not going to tell me anything. It's likely going to minimize it, and that's not what I want to do. So, instead, I'm going to look at the critical value from this, which is r equal to 3, not 3, it's equal to 200 over 3 centimeters. Now, it says what are the dimensions, so I can't just give the radius. I want to give this as well. I want to give the height. So the height is, and I use this equation right here, it's 100 minus r, which is 100 minus 200 over 3. If the question asked us to justify that it was a, I think we can assume safely that since this 200 over 3 is between my domain of 0 and 100 for r, right? That's the domain of 0 and 100. It's not going to be smaller than 0. It's not going to be bigger than 100. Since 200 over 3 is in between, I think we can safely assume that it's a maximum. If it asked me to justify it, then I could take a second derivative, and I would see that it would be concave. What is it? Concave down, because I would have a negative coefficient, which would mean the fact that it was a maximum. But I don't need to justify any of that. This is my answer. You still listening? I'm impressed.